Hello everyone, welcome back. My name is Jim Lewis. I'm the founder of Model Train Technology. Today we're going to talk about ground signal interlocking. And what interlocking is the process of connecting the signals between each of the turnouts in say a freight yard, so that when the lead switch to the main line is closed, in other words set to the main line, all of the switches on the sidings, all the signals should be red because they don't have a clear path to the exit. The Dwarf controller that we announced last month has full interlocking in it, both for DCC and for wired. And we're going to demonstrate in a couple of minutes the DCC version, simply because on my desk there are fewer wires for me to connect up and tape down. But the process and the technique is the same. In the case of a wired setup, we have our coil detector. So if you have a coil-based system, not DCC, no DCC anywhere around, you can use our coil detector. And what it does is it connects to the power that you use to turn your switches or your turnouts. And whether you use a push button, a slide push button, or maybe a Kato lever, whatever kind of toggled relay, whatever kind of system you use to turn the coil-based switches on your layout, you hook up this two wires to each of the switch outputs, and there's one signal wire that goes from this to the input of the signal controller. It's just one wire, and what that will do is this keeps track each time you switch the lever in your coil-based system. This senses the current and keeps track of that. So even if you turn the power off, this little board, the coil sensor, coil detector, will remember which position the switch is in. And that's really important because if the lights come on for the signal controller, you want the lights to remain in sync with your physical switch on your layout. So between this little connector for your coil-based systems and the Dwarf Signal Controller, you can do that. Same controller for DCC. It's the same product. It has both of those capabilities built in. And here are the Dwarf signals themselves. We're going to call them D signal controllers in the documentation. Fewer letters, I guess, easier to say. These are the S scale and O scale version. HO is a bit smaller and N scale is really small. In this product right now, all we have, we're using exclusively fiber optic. Over the last 6 months in particular, we found fiber optic in our system with the pins and so forth to just be really easy to install. And we like the lighting effect. The light comes out the end of the fiber, straight out the light. We create a little lens on there. We have a special patented process for creating the lens on the end of the fiber. And we color them red and green in this case, or red, green, and yellow. And it's super simple and they look great. LEDs, you always have the problem with soldering the fine little wires that come out. I got tired of that. I don't know if you have yet, but so this is really a great solution for that. Super simple. And the fibers, it comes with a 3-foot fiber, which is usually plenty for switching in a yard. But we do have a couple occasions where a customer will have a very large yard and want to put a signal in parallel, and you can do that with our signal controller at each end of the siding. And in this case, it was almost 25 feet away. So the cable, you can buy longer lengths, up to 25 feet is, you can get away with a little bit longer, but if you have two 25-foot lengths and you put the signal controller in the middle, that's a 50-foot span. I don't know if many people in their basement have a 50-foot span of a single siding, but you can do it. All right, so let's get into it. I built a little mock-up drawing, and we're going to connect up 4 of the signal controllers in interlocking mode. So let's go to it. Here's our sample siding setup, and we just have a piece of paper and printed out a schematic for the turnouts. We have 4 of the signal controllers, and they're simply connected to DCC. There's no other wiring. That's it. Now, I've already set this up. In a couple of minutes, I'll show you exactly how we programmed and configured each one of these. But for right now, I just want to show you how it works. So I used a little bit of fiber, thicker fiber. I painted the end of it with some translucent color, red and green. You can see it better highlighted on the layout paper than you can actually in the lights. The camera sort of dims it a little bit, but you'll get the idea pretty quickly. All right, so here we have a main line, and right now the turnout is to the right side green, so all of these are lined up. So the main line is closed off, so that'll be an indicated red on the dwarf signal. Green going up to here to the first switch, green. So this is closed. So this is thrown. I don't know if you can see the letter back there. Closed here, thrown here. And then the switch reverses. So thrown is this way, closed is straight on the continuing up. Another closed switch here. So we have green and we have green. So all of these are clear all the way up to the top level signal. And the numbers here, the big numbers, are simply the DCC addresses. You can use any number you want. They don't have to be in sequence. Any one of the 2,044 addresses that are the standard DCC will work for any of these. So, but just to make it simple on my push button and to keep the concept simple, 3, 4, 5, 6, I've just programmed each of these with the primary address. So if I dial in turnout 6, and these, by the way, these would be the same turnout DCC address as your turnout. So you don't connect anything else, don't disconnect anything on your layout, just note what these numbers are if you have that kind of system. If you had an icon-based system where you have to sort of dig to get the number, it doesn't matter because you're just going to flip the switch to program these. So I'm going to turnout 5 to configure it. You'll see that again later in the configuration demo. Right now, I'm going to select turnout 6, and I'm going to put it in the thrown position. So that way, right now it's set to straight. So I push T, and now the main line, extended line of the siding is red, and the siding over here is green. So that's pretty straightforward. All right, so either way, that way. Likewise, I can do that with 5, thrown. Now notice what happened here. So now I have turnout 5 going to the siding, which means this connection here is red, which means this turnout at any train here does not have a clear path to the exit. So what happened, despite whatever position switch 6 is in, the signals will both go red. Now, if you subsequently, while you're fiddling around, change turnout 6 back and forth, the signals here will stay red, but it's going to keep track of what direction the turnout is in. So let me show you that. So we're going to go back to 5, and we're going to close it so we get access over here. So now you see that switch 6 is in the main straight line and not to the siding. Let's change that and 6 and make it thrown. Okay, so we've set it to the siding. Now we're going to go back to 5 and cut it off, set it to the siding. We'll go back to 6, and I'm going to change it to closed. Remember, before we locked it or interlocked it, it was in the thrown position. I'm going to push close. Nothing's going to happen here, but your switch will have turned. If we now go to turnout 5 and turn it back to the closed direction, you'll see that switch 6 kept track and now is in the third direction. So behind the scenes, it's going to keep track of it. All right, let's go all the way back to the main line here. Remember, we had it green going all the way up to the siding area. We will change it to closed. And what you'll see is, okay, now there's no path to the exit, if you will, for all of the other sidings, so they all turn red. If I change 3 back to thrown, they'll all resume back to the exact position of your physical turnout, whether you were flipping it around while it was in the lock position or not. Now, one of the other cool things is I'm going to put this back on closed for 3, so these are all red. At the end of the day, when you turn the power off on your layout, most systems just forget what state they were in. But what we have here is it's all built in and we keep track of that. So the state that all the turnouts were in when you turn the power off will be the state they're in when you come back the next day, whether you have them in sidings or whatever flipped around. So that's really great. And that works as well with the wired version. So those folks out there that don't have DCC but have the wired and the coil version, the coil sensor keeps track of what position the turnout is in and it remembers that position even when the power goes out. So in that case, the signal controller doesn't remember what position it is. The coil detector does, but it has the same effect that it'll remember and set the signal lights in exactly the same position as you left the night before. Now, right now we have these on instant mode, and let me see, let's go here. Let's turn to switch 3 again and put it in the thrown direction. Release all of these all the way up the line. Now we'll play with 4, and we're going to put it in the thrown position. Now you notice that nothing happened to 3 because it's downstream of that, so everything upstream. Now if you have a branch line that comes off in a different direction, let's say right after 4 but before 5, and went down here, you would load up the interlocks for these two, but not these two. So you can mix and match sections of the interlock as they branch off in different directions. And in fact, if you wanted to, you could put the interlock for 6 and 5 together, but skip 4 and 3 going to the exit. It really is up to you. It's how many you want to do. And each signal controller can handle 25 interlocked switches. So that's a really huge layout, siding setup, but that gives you plenty of latitude and leeway to configure as you want. All right, one other thing, everything is programmed with the push button. I'm going to show you more of that in a minute. One thing I just want to show you real quickly is the fade mode. So right now we've been using instant on and instant off. I'm going to go 1, 2, 3, 4, 5. And this one was already set in the fade mode. So this one's instant on, and this is, you can see it's a slower pace on and off. So just some variations there. And so let's go talk about how to configure this. All right, this is how we set up the configuration for interlocking. I'm going to use 4 signal controllers. These are all from the DCC line. And the first thing we do, of course, is just plug it in and power it up. And I'll do that right now. All right. So very first thing we want to do is give it an address. It's been reset. It's in the clean state. So to give it an address, I'm going to give it address 3. I'm going to push and hold the select button, and I'm going to wait till the lights come back on, and then I release. I wait till both the blue and the lights are blinking like that. Now I take my DCC hand controller, select switch 3, and when you're giving it a primary address, doesn't matter whether it's closed or thrown. Later that will matter when we load the interlocking addresses, but to set this to address 3, I'm just going to use thrown. It's going to do it, and there it is. So the left hand, by default, the signal controllers have 2 DCC addresses. So the left one I'm controlling with switch 3, and the right one is switch 4. So that's what you would do if you're not doing interlocking. If it just switches out in the layout, you can hook up 2 turnouts to a single signal controller, and away you go. What we want to do is use interlocking. So let's enter interlocking. That's 8 pushes of the button. 1, 2, 3, 4, 5, 6, 7, 8. And it flashes. And now when we change the signal, both lights go at the same time, okay? So that's what we want, because you're going to have the lights alternate all the way down the line, just one set of lights for each turnout, all right? So that's how we have that set up now. If you don't want to use the second lights here, you can set it and just turn the LEDs off by adjusting the brightness to 0. That's pretty straightforward. All right, so that's number 3. It's the main entry point, okay? The second signal controller would power up. Okay, we're going to give it address 4. Same routine. I'm going to dial in address 4 and give it a thrown. And I'm going to, so it's not in interlocking mode yet, so we've got addresses 4 and 5. So there's 5. All right, now we're going to put it into interlocking mode. 1, 2, 3, 4, 6, 7, 8. And now the two lights will work in concert with each other. All right, so the very basics of setting up interlocking is to now load the address of 3, or this turnout, into this controller. I don't even need to know necessarily if I'm an icon-based system that this is address 3. All I need to be able to do is throw or close this switch while this is in a kind of learning mode. So the way to get there is we're going to do the same hold and press and hold for address setting. All right, and it's going to blink. But instead of putting an address directly in right now, we're going to push this twice. And now it blinks a couple of times. Now it's back in address loading mode. So what we want to do is this turnout in the closed position blocks the traffic. So what we want to do is enter in the turnout number 3 with a thrown command, not closed, but a thrown command with address 3 into this controller. And so what we're doing is telling it the thrown position of the signal ahead of you is thrown to give the clear access. So I dial in 3 and hit thrown. And this will blink this will go out, this will blink a few times, and now it's ready to accept additional addresses. As we get further on and add more controllers, we'll add more addresses. We'll just keep going. So we're still in that mode. To exit this mode, press once. Okay, so this turnout is now in, let's see, well, we've got this in, let's put this in linked mode. So what I'm going to do is change this so that the left and right ports are behaving identically to each other. So they're shifting together. All right, there we go. So now we've got thrown in this direction, and up here, we've got full access to either side of the switch, okay? If we change 3 to the closed position, right now it's red to closed and green to thrown, what we'll get is a lockout or interlock of this turnout. And so what we're going to do is we're just going to keep repeating the process. We're going to add another signal controller. We're going to give it power, and you guessed it, we're going to give it address 5, and then we're going to load these two addresses and tell it what path is clear to get to number 5. So in the first case, it was thrown, but in the second case, the turnout 4 will be in the closed position. So we have a thrown position and a closed position to demonstrate that you can choose either one to get it the clear path to get to turnout 5. All right, so let's go back through the routine. We're going to program in the address for this turnout. And this will be the same turnout numbers that you have in your layout. You don't have to do anything with your layout. All right, so now we're just going to give this an address 5. And after giving it an address, it just goes back to its normal mode. And we still have, we're in standard mode, so it's 5 and 6. Here's 6. Okay, so we're going to put it into interlocking mode. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now both sides are going to behave together. There we go. And now we're going to go back in and add just these two addresses. So we're going to go back into address setting mode. And the light came on, I release, let it blink a couple of times. 1, 2. And now it's in address load mode. So let's do this one first. So to get to the clear path to the exit is a thrown on switch 3. So we're going to hit switch 3 and thrown. And this is going to go off, and the blue light will blink a few times, and then it will come back on blinking. So it's ready for the next address. So let's add the next address. That'll be switch 4 in the closed position. So dial in switch 4 and closed position. This will go off. The blue light is blinking. and now it's ready to add additional addresses. You can add up to 25 sequential, not sequential, but 25 different addresses. And so it's just going to continue to wait for me to load more. To exit this and save what we've got, just press this once. Okay, so that's all there is to it. So now let's look at what we have configured. We have this in the thrown position. We have this turnout in the thrown position. And we now, and on switch 5, while they're in the, this is in the thrown position, or closed, and this is thrown, we can move this switch and get access. Now, as soon as either one of these is changed away so that there's not a clear path for any engine coming or any train coming on 5, these will both turn red. So let's do 4 first. All right, so now we're going to throw in, and that cuts off 5, and you can see they both turn red. So let's show that again. We're in the closed position, got full access. We go to thrown, and these both go to red. And this will just cascade all the way up as you saw earlier. All right, so let's get this back to closed and try the same thing back here. We're in the thrown position, green is on the right. I'm going to close this to have traffic go on the main line. And you can see now that both 4 and 5 are locked out. And that's exactly the way we want. So again, we would just add the next controller and set it up the exact same way.